Alright, so before we get started with today's video, I thought I'd tell you a quick story. I was helping my daughter, and her assignment was to make a video doing an experiment to show some of the fifth graders in the school or something. So she was doing the video, and I was helping her edit it, and she pointed out something that I wish I'd known when I started making these videos, 70 videos ago, and I've gone all this way without using it, and it's that I can add background music to these videos. So without further ado, all right, so today we are going to look at the next function, which is cosecant of x. Okay, and in order to think about the graph of cosecant of x, we are going to remember how we graphed sine of x, because cosecant of x is just 1 over sine of x. That's one of the things that you had memorized on your note cards. So let's start by thinking about the graph of sine of x. And we can get that by plotting some points, but we should also know what it's going to look like. But I thought I'd write out the points just so we could see them. So we have our first point at 0, 0. We move over the period, halfway in the middle. Those are our 3 x-intercepts. And then at pi over 2, we go up to our maximum. At 3 pi over 2, we go down to our minimum. And so we can draw our curve. Like that. And if we wanted to, we could add in a few more points. We could plot a few more frickin' points. We could put in pi over 6, which, good thing we have that memorized, is 1/2. We could do this one here, which is pi over 3. That would be the square root of 3 over 2, but I'm going to jump. So that was pi over 6. I'm going to jump here to 5 pi over 6, which you can see is also 1/2. And then, let's see if I have enough room here. I'll squeeze these in. I'm going to get 7 pi over 6, which is negative 1/2, and that guy there, which is 11 pi over 6. I don't know if that's on the screen, but it's negative 1/2. You can see it in the graph. And so we're going to use that to help us graph cosecant of x. And the way we're going to do that is we're going to take this and we're going to make another row, I suppose column, on our chart here, and we're going to call that cosecant of x. So if cosecant of x is 1 over sine, at 0 we have 1 over 0, which is undefined. So these are all undefined. And then we have 1 over 1 is just 1. 1 over negative 1 is negative 1. And then 1 over 1/2 is 2. These are both 2. These are going to be negative 2. Okay, so let's go ahead and throw those on our graph. I should have done those in a different color, but well. So I'm going to skip the undefined ones for now. At pi over 2, we're at 1, so that's that point right there. And at 3 pi over 2, we're at negative 1, that's that point there. At pi over 6, we go up to 2. And at 5 pi over 6, we're also at 2. And then these ones are negative 2. And so when we think about what happens is this gets close to a y-coordinate of 0, we'd be taking 1 over things getting close to 0, which are going to go off to infinity. And so what we have here is, as my cord flaps in the wind here, we have a vertical asymptote. So basically, wherever there are x-intercepts on sine, there is a vertical asymptote on cosecant. And so this gets close to infinity. So we come down here, and what we have are these U shapes, just like that. And so that is what the graph of cosecant looks like. And it's going to repeat because as sine goes back up, you're going to get another U shape going up and down. So when you're looking at this, you should be able to quickly tell me that the period of cosecant is 2 pi. In general, it would be 2 pi over b, just like sine. And the phase shift, or the horizontal shift, works the same way, be c over b. And then the vertical shift is D. So if the midline is shifted up, then this gap that's in between these U's is going to be shifted up. And what are we missing? We're missing the vertical stretch. And the way you see the vertical stretch is by looking at, grab another color, this distance here from the minimum of the U to these points here, which I usually call the third way points, because they are a third of the way between the asymptote and the minimum or the maximum. Okay, so the third waypoint, the distance, the height from the minimum to the third waypoint is equal to the vertical stretch, which is A. And that's the basic idea of graphing cosecant. So let's just see it again, and then we'll do one with some different numbers. Whenever I graph this, I usually think about where sine is. So I know sine is going to be here. I'm going to just sketch this in real quick. And then I can put in wherever the maxes and mins are. Those are going to, the maxes and mins of sine are going to be the minimum and maximum of cosecant. I know the zeros correspond to the asymptotes. And then the third waypoints, I go a third away from the asymptote in, I go up the A value, or the vertical stretch, and then down the A value. Then I can draw my curve. And notice you can see where sine is supposed to be, but your graph should not actually include sine, so that's why I did it in pencil, so that I could erase it out and show you that that's what the graph of cosecant actually looks like. And again, it's periodic, so it will repeat just like that. All right, so let's look at another one. And let's throw in some numbers so that we have a little more complicated one. Hopefully you guys are enjoying this music. I can't actually hear it yet because I will add that when I go to edit. So hopefully I made a good choice on the music for this video. Let's look at y equals 2 cosecant of 2x plus pi over 3 close parentheses plus 1. Okay, so we need to find the period, which is going to be 2 pi over b, which is pi. We need to find the horizontal shift, which is c over b, so pi over 3 over 2. Hopefully, at this late stage, you guys have finally gotten the hang of clearing out these fractions. That's going to be pi over 6, and because it's minus, it's going to be to the left. No, I said it's minus, it's plus, and it is to the left. What else? We have a vertical shift, which is up 1. So when I think about where sine is going to be, the midline would be y equals 1, but we call that a vertical shift of 1. And then there's also a vertical stretch. That is by 2. Okay, so I do not have a set of axes prepared, so I'll throw that in here real quick. Let's grab the black. So this is good entertainment. So if you guys are enjoying this video, you should like and subscribe, and click the bell icon so you get notifications. I don't know, my kids have been telling me I should say that in my videos. I don't know if that's funny. I figure now that I have the professional quality of the background music, I should start my YouTube career, as Forrest used to say one. All right. Okay, so we're going to start by sketching in sine. So it has a midline of 1, so that'd be like right here. I don't know if you can actually see that, but I'm doing it very lightly. And then the phase shift would be left pi over 6, so that's just one block, would be right there, which means my first asymptote would be there. And then I move over my period, which is pi, so it would be right here. That's my second asymptote. And then in the middle would be my third asymptote. And then I need to go up to my maximum, so it's a vertical stretch of 2. The amplitude of sine would be 2, so I would go up to here. Oh no. I don't know if I left enough room on my graph. We'll find out in a second. And then my, oops, that's not the right place. It'd be halfway in the middle, so it'd be right there. And then down to would be here. And so that's the maximum of sine becomes the minimum of cosecant. And similarly, that point becomes the maximum. And then from here, I have my third waypoint, which would be right there and right there. I have to go up 1, 2, 3, 4 halves or 2. So I have that U right there. And then I go down to, should be right there and right there. Notice that those points are closer to the asymptote than the center point there, or the max or the min. So there are my two U shapes, and that is that cosecant function. All right, I think that's it for today. Let's give you some quick steps. I guess I can make these up as I go. So you want to think about sine. So the graph of if this were sine, and then you need to put asymptotes wherever the midline points would be. Like the x-intercepts, but if it's been shifted up or down, those become the midline points. And then halfway in the middle, those are going to be your max and mins of the U's shapes, the U shapes, and they correspond to the maxes and mins of sine. And then you get your third waypoints, which are closer to the asymptotes. And they go up from the max and mins, so up from the max, the vertical stretch, and similarly for the down from the min. That's the basic idea. I do want to tell you two common things that I see when I see people graphing cosecant. First thing is, so let's say they're graphing and they draw their asymptotes wherever they are, and they put their maximum here and their minimum there, and then they go like this and they draw their U's like that. Okay. Or they just do like that. What you have to remember is that wherever you draw this, you should be able to picture a sine wave in the middle of it. You should leave room for the sine wave. So if we go back to our original graph here, you can see sine is in between. There's like a gap in the middle of the function where the sine function would be. Okay, so make sure that when we're graphing sine, when you think about graphing sine, that you have that gap there. All right, guys.